So we had some good questions on that last question on knowledge check 3, where I asked you if there was anything else you wanted to know more about. Two things kind of rose to the surface: box plots and standard deviation. So I'm going to break down box plots in this video, and I'll do standard deviation in a second. So with box plots, there's basically two things that are all you need to know about box plots. In terms of a box plot, you need to know that each of the components of the box plot that we use to build the box plot, they represent part of our 5-number summary. So we have our min, our Q1, our median, which is also Q2, Q3, and our max. This is usually enough to maybe answer a question, right? If we wanted to know which place had the, or which group had the highest test score, we'd just look at the overall maximums. If we wanted to know which class had the highest typical exam score, we'd look at their medians. We can even get some measures of spread from this, even though it's not done as, it's not as explicit. We'd have to do a little bit of work. We can obviously find the range. That's the distance from our max to our min. And we can also find the IQR, which is our distance from our Q1 to Q3, the actual length of the box portion of the box plot. And so this brings up two mistakes I see from students quite frequently when it comes to talking about box plots. All right, mistake number one is talking about the mean. The mean is not something we can see from a box plot. In fact, this was a common error in my spring classes on their final project. A lot of them were talking about the mean of these two things, and we only had a box plot. So we could only see the median. That's the only measure of center we should really be talking about. We could potentially infer things about the mean in terms of looking at, if our box plot looks pretty symmetric, that means our data set's probably symmetric, and we can probably say the mean and median are close. But there's a lot of arguments about whether or not we can even talk about symmetry looking at a box plot. So just don't talk about the mean. So mistake number two is talking about the IQR as a location. And I know that sounds weird, but again, thinking towards that final project, I had a lot of students that when I asked them, what about the box plot led you to a certain conclusion? Students would say the IQR for this group was larger than the IQR for this group, for the other group, was higher than. And what they meant was the entire box, right? From Q1, the median, Q3, that entire box was shifted to the right. But the IQR itself is a singular number that talks about spread. So you don't want to be using the IQR to talk about a typical or a difference between two groups unless you're talking about how spread out or variable the measures are for those two groups. So that is the first thing we can see from a box plot and some of the issues that I've seen from students in terms of interpreting that. But then most of the questions I ask on a test in terms of multiple choice come down to a second thing about box plots, and we saw this. And that is that each of the segments of this box plot, each of the things, these areas delineated by our 5-number summary, represent 25% of the data. And this can be kind of challenging to wrap your head around, because when you can see, especially, let me move this max out for a second, just to make that to make this a little more of something we might have a problem with. When we see that whisker being so much longer on the right side than the left side, it makes us feel like that represents more. But it doesn't. It just represents more variability in that particular segment of our data. So each of these segments represents 25%. There were a number of questions in this week's knowledge check that had you come up with numbers of things in that percentage. That's another warning, another mistake students can make. The AP loves to test these types of questions. We cannot see the number of things in a box plot. All we have are percentages. So if you have two separate box plots that you're comparing, this is a favorite of the AP, they'll say like, oh, there are more people in this area. We don't know that unless they've given us sample sizes. So we did have a number of questions in Knowledge Check 3 where I gave you a sample size. I told you, let me go look, there were 280 values in that sample. So 280 things were represented in your box plot that looked kind of like this, which means 25% roughly, you don't, I mean, kind of squint at it because technically some of the things are falling at exactly Q1, and just squint. I know this is the difference between math and statistics, is we kind of say ish a lot. But if you think about each of these segments, they're each going to represent 70 batters. And yes, I was doing that in a calculator because I truly am terrible at simple math. So each of those has 70 batters, and they're just distributed in some way that we don't know. Those 70 dots could be anywhere in that whisker. So knowing these percent breakdowns, knowing what each part of the box plot represents is pretty much the key to success for these questions. So just know, as long as you know those two things, you're going to be good. That's what you need to know about box plots.